Like just some random runaway? Oh, okay. We won't snitch. Yes, we are recording. You may not want to answer now. Okay. They had a tip? Oh.
Who hates you that much?
Either that or they just think Grant's a runaway. Okay, so we talked about this on our warm-up already, which is lovely. Avery, do you know how much attention Garrett paid while you were not here? So much. Garrett, maybe I need to move you. I know, but he was going to start talking. Okay, so we're talking about something called antiderivatives. So an antiderivative is what we did on our warm-up, where you just go backwards. So if you know the derivative, then you can go backwards and tell me what its original was just based on the pattern. As Joe said, you're just using your brain. You're just thinking about it and you're writing it down. Just a second. So, let's say, just so you have this on your paper, f prime, let's say f prime was, this one is awfully easy. Okay, so let's say we've got that. I'd like you to find the antiderivative for me.
Will you ever end up giving us a value for C?
Oh, what a great question. We're going to talk about that today.
It's just not real. Is there a special notation for an antiderivative?
Yep, we're going to go there too. Okay, so if f prime is 4x cubed plus 2x plus 7, what's f of x? Okay, so that C, the reason it's a C, you guys are smart and you figured it out. It could be anything, right? It could be any constant number because the derivative of any constant is what? And so then it goes away. So you never know what's there. And so if you see there's actually a poster up there that reminds you not to forget your plus C. The C is there. It's just the indicator that there could be a constant. And so it's C for constant. That's why it's a C and not a D or some other thing. Okay?
Doesn't it not really matter that much, though? Because isn't it just like a y-intercept and a polynomial?
It's not unimportant, though.
Okay.
How about this one? So let's say we have f prime of x equals e to the x plus 4 cosine x.
Are there any things where the derivative could be the result of two different equations? Two different things make the same derivative?
Oh, no.
Positive sign turned into positive cosine and negative sign turned into positive cosine.
No, because there's a negative.
That hurt my brain. Just a second. Let me answer this question. Let's do this question and then I'll answer both of those questions. What's the antiderivative of this?
X plus 4 sine x plus C.
Okay, so Caleb, your question about the negatives, you want to say what that was?
Yeah, couldn't that be a negative 4 sine x?
What's the derivative? So this is This would be like when you have a question like Caleb's, and you're like, couldn't this be that? The way that you do this is you check to see what's the derivative of the thing that you wrote down. What's the derivative of sine? Positive cosine.
But the derivative of negative sign is also positive cosine.
No, it's not.
No,
The negative would be hanging out still.
because the negative is that negative is hanging out still. It's just a constant that you leave in the front. It would work just like the 4. Mm-hmm.
Dude, there's something about how cosine turns into negative sign or what
Cosine turns a negative sign.
But that's its derivative, though. The derivative of cosine is negative sine. So if this, Caleb, here. So let's say we had this.
It would only happen if you had double derivative.
Okay, so let's try this one. Okay, try that one. So Mason, I think the answer to that is yes, it could happen, but the two equations would be, one would be simplified and one would be unsimplified. So they would be the same equation themselves.
Oh, like one of the proving things? Like,
Yeah, it would be something very complex and then something simpler.
Yeah, like when you have to like divide your thing by like
Yeah.
1.
And anything with C's is obviously different.
Say again?
And anything with different C's.
Correct, obviously be different, but
What times 4 is 5?
that's a great question. That is the question you need to ask. Okay, so this is what I want you, this second. This is what I want you to think. So Caleb said, what times 4 is equal to 5? You can solve that. Okay, Ashton, did you get it?
5 fourths x to the 4th plus cosine x plus 3.
There's your sine and negative cosine also, Caleb, because the derivative of cosine is negative sine. Okay, so sometimes you really truly you need to think exactly like Caleb did. You go, hey, this is supposed to have been multiplied by 4, so what times 4 is equal to 5? Write it out and go, oh, I have to divide. David, you can have 1.25. That'll be totally fine. Good news. We don't undo the quotient rule in this class. Other good news, we don't even undo the product rule in this class. Okay, that's something that's reserved for calculus 2, and there's a formula for it. It's called integration by parts, is what it's called.
Is it really that much harder?
Miss Douglas.
Yes.
We'll get chain rule thing.
We will do chain rule things that not even like the one we did on the board was the easy chain rule. So maybe we'll do easy ones now. We'll do harder ones at the end of the chapter. Caleb.
Is there any words of encouragement you can give to a student who thinks that they've hit their plateau in learning math?
Like, have to keep learning.
No, but I'm at the point right now where like I'm here and everything you've said just goes in one out your, in one ear and out the other ear. Like I'm not learning anything.
I mean, you could find them less instant.
You did.
Something.
So here's what either way you have the capability of recognizing the problem.
Yeah.
Right? So my thought to you is everybody, number one, everybody hits that. Okay? It just may not be here. That's why this is a small class, because everybody else hit that elsewhere. Right?
Yeah.
I hit it in college.
Yeah, probably like Calc 6.
Definitely sat in Calc 1 and had a professor that like you guys, I did not I independent studied math my senior year because it wasn't offered in my like senior level math wasn't offered. So my professor assumed that I knew what the difference quotient was. Like I walked into Calc 1 and I didn't know.
Is that cultural?
F of x plus h minus f of x over x minus h. Like you guys did that in pre-calc. Never seen it in my life. Like I felt like an idiot. I made it. I'm okay. I got an A. It's okay.
That's the difference, Douglas.
So I hit the wall in something called modern algebra, which had nothing at all to do with algebra. I don't know. I don't know. I was at the Caleb spot where the guy would say the things, and I was like, that was all foreign language, all of it. You guys try this one.
To your topic about energy drinks on a ban from Steve has banned me.
That's probably wise. They're terrible for you people. We're not even gonna have an argument about it.
It's not even about that. It's I have a teacher that no, yeah. Stop.
Yep, good plan. Okay, try this guy.
Oh, I just realized why the product rule and stuff would be hard,
Because how you gotta figure out the.
that you don't know that it's the, because it's still
Yeah.
parts.
Yeah.
No, not yet.
Oh my heavens!
Dude, you gotta move them from Avery right next to me. I'll keep them in check.
Why would it be hard? I was running it through my head, and I was probably figuring out how it would be
Because it's stiff. It could look like chain rule.
Yeah. And is it a multiple product rule? Is it a chain rule? Like, it's hard.
I'll trust you.
What's the answer?
X squared.
Yeah,
Let's see.
let's see.
Gosh, I'll never get it.
Because the 2x, so Mason was asking about the chain rule. This is as difficult as we'll get into the chain rule right now. We will get into some that are a little harder, but there's a technique that you use. It's called U substitution, which you don't have to worry about now. It makes it easy, makes it a lot easier. So we're going to teach you a way that makes the harder ones easier.
Are we gonna do like natural log and like?
Eventually.
Okay.
Natural log has a weird antiderivative.
Well, yeah, because it'll come as one, like the whole thing over.
It's strange business. So he's later in the chapter. How about this? Let's do 7x squared plus.
So all these times when they've been giving us like the f prime and then it's like describe the function of f and like the behavior of f, why don't we just do this?
I tried to do it on the test and there was a line.
Like reverse engineer it and just get the f.
Because it won't be like that on a test. It's going to be like, here's a graph to say the things. Here's some function that you can't reverse engineer. That's the problem, right? They're going to be like, here's f prime. There's no way you can go backwards. Realize that we're dealing in polynomials because they're easy. Okay, there's definitely two parts of this one that I want to make sure that you understand why they are the way they are.
I have to like set up one of those little Punnett squares.
Feels like it.
I think I got it.
Okay, what's the first one? First term. 7 over 3x cubed. Okay, now, the way that we get that, you know that this has to be a 3, right? Because it was differentiated, it was a 3. So that means you know that this was something times 3 equals 7. So same thinking, something times 3 equals 7. So solve that and you get 7/3. So David, this would be why we want to leave them as fractions because they're always not going to be nice. Okay. Oh, there's totally a pattern, Mason. Okay, now, what's the next one?
Half x squared.
Yes. Caleb, how'd you come up with the half?
You had to get 1x.
Bingo. This is 1x. And so 2 times something has to equal 1. Okay, what's the last one? 4x plus c. Plus the c. Okay. Try. Let's see. Okay, let's try this one. And then let's also try this one. This is 6e to the x. Okay, those two, please.
just say it's a constant?
Nope. Okay. Tell me, how about what's F? What's the antiderivative of F prime here?
60 of X.
Yeah. Plus C.
Oh, that's what I think.
Okay. 6, this 6. Well, we'll talk about him in a second. How about G?
1 plus sine of 5x plus 3.
Sine, yep. Yep, because that's that one again, right? That Caleb was talking about. That's 1 cosine. You know that this would be an undoing of the chain rule. There should have been a 5 up there. There's no 5. So a 5 times something had to equal a 1. If you're like, nope, that's beyond me, we will be back to talk about chain rules eventually later. I think about what I want to. Let's say you're working on something like this. Although you guys really did pretty good on this, so I don't really feel like I need to talk about this a lot more. $12x to the 3/5, please.
Can we ever get them where it's a negative exponent simplified?
Yep, for sure. That's a good question, and we'll do one of those too.
Oh, shoot, we need to flip that.
You really do kind of almost need a square. Maybe I'm just not good at it.
Just gotta. So, you guys, I think one of the things that makes this challenging, and I don't want to say that this is not super difficult, but the thing that makes it challenging, in my head, this is how I think about it, which doesn't mean it's going to be helpful to you. You have to kind of work forward, and then work backwards, and then work forwards again. So, backwards first, maybe. You have to ask yourself, okay, the first thing that you know is what the power had to be, right? So there's your backwards. Okay, what did the power have to be? 8/5. How'd you get that? Yeah. So this would be add 1, right? But when you add 1, that's 5/5. So it's 8/5. And you have to divide the 12 by 8/5 because 8/5 times something is equal to 12. Oh, lovely.
The issue I have is I'm like, I can do this in my head.
Can we write 12 over 8 fifths?
No.
You'd have to simplify it.
You can do 12
Yes.
8/5 in your calculator.
Yep.
Yeah, that's what I did.
Okay. You cannot have a complex fraction. So 60 over 8, which is 5/2, is that 15 halves? So 15 halves x to the 8/5.
But you could reorder it if you did have one like that. If there's like a no calculator question or something, right? Like if you got it.
Yep. Yep.
Keep switch flip.
Yep. Keep switch flip.
Oh, let's see.
Okay. So that's the general idea of an antiderivative, but
Thou shalt not forget.
bless you. Yep. Good catch. So, couple things that. Oh, okay. These are called antiderivatives, but they also have another name.
Everything is so clear.
Okay. These are also called indefinite integrals. So I want to remind you, there's 4 major topics in calculus. Limits, derivatives, which we've talked all about. And then there's definite integrals and indefinite integrals. Okay? We're talking about both of those things in this chapter. Actually, we're talking about both of them this week. Okay? Definite integrals and indefinite integrals. So called an indefinite integral because it is. I don't know why, because it is. Okay? And it has a symbol. It has a symbol to it.
Oh, I think I
Okay?
see this.
So the symbol is actually this S, a long S thing.
These are the memes I see, Miss Douglas, where they say, "Don't forget your seat."
Yep.
I see where you're coming from now, Caleb.
So something like this,
Yeah.
something like this means the same as me saying, hey, f prime of x is equal to x to the third, find f of x, or find the antiderivative. This is
an integral sign?
it is an integral sign.
I'm gonna have to learn how to do that.
It's just a big S.
Oh, mine's ugly.
It's just a tall, skinny S. Okay, so this is an integral sign. It's an indefinite integral. And then, so the nice thing about this is you don't have to worry about your notation. You just say, this is equal to this. What's the answer?
1/4 x to the 4th plus c.
Plus C.
What? I'm confused. What is that thing by the D right there?
This is a dx. Okay, so
And then because it's whatever.
Integral. Then it has to just have the S. It literally doesn't change anything.
it doesn't change anything.
Oh, okay.
Okay, so I could write, like you could do, let's do this one. Let's go 3x to the 4th plus 6x minus 2 dx. Okay, so a couple things. I'm going to tell you what all these these are not people. I'm going to tell you what these pieces are called. This piece right here is actually called, this is the integral sign. We just talked about that. This is called the integrand. It's basically the thing that you're doing the antiderivative of is called the integrand. And then this guy is called a differential.
This one.
Yep.
Will there ever be an equation where you have to do double derivatives and find the original?
Sure, we could do that. I'll show you that too.
We need to know it's called integrand.
Do you not need to know that it's called the integrand?
Are they going to use that terminology on the AP test? Is what I'm asking.
I don't know. I would say no. They're just going to write it. Okay, so this integral sign is the function that you're integrating is called an integrand. Who cares? It's like when you do the long division, they're like, this is the quotient, and this is the dividend, and this is the divisor. Who cares? I just know where they go, right? So this thing here, this is an important piece. It's going to seem like random, and it's going to seem little, but it comes back. This variable has to match this variable, right? If this is a dx, these better be x's. Okay? But the answer is just the answer. The dx goes away. It's an integral. Just do the math. What do you get?
3 plus x plus 3x squared minus 2x plus c.
Yep.
What if it's one of the things that has two variables in it, like there's y's in there too?
Can't do that. That is a class. It's calculus 3 or 4, depending on how your university does it, or they will call it multiple variable calculus.
If you make it Calc 4, who actually just math teachers need to take those far?
I think my sister's doing that stuff
Yep.
right now.
Engineering,
Engineers and math teachers.
physics people going into physics.
You probably just some just.
So Mr. Hoover took these classes.
My mom was supposed to be a math teacher. I went up to her the other day.
Probably. Well, I don't know if physics teaching is different. Okay, so these are called definite integrals. Now, let's see.
When do we start doing proofs?
No proofs.
51. She's like 3/4 of the way to 10.
Your mother is not 51.
Yes, she is.
She is not. She's 50. Bet. Caleb Vicia
What are we putting on it? Wesco coffee?
or donut.
Wesco donuts?
Okay.
On what?
I'm winning this one.
Who shoots her a text? To ask her the age. Or do we give her a ring right now? I'll call her. It's got real.
Not speaker. Everybody else has to be quiet.
I just somebody's getting mad.
And just tell her that we have a bet.
Hey, Heidi, how old are you?
She's probably on lunch. Yeah, you're right. If it rings more than 4 times, right?
I have a bet with Miss Douglas about how old you are. Can you tell me your age? Okay. Love you. I thought you were 51.
Wait, give it up. I can't believe.
She's younger than me. She's a November baby, and I'm an August baby.
How am I supposed to know?
But we were all born in the same year.
Correct. She's an April baby.
Yes.
That's me, that's you.
Yeah, exactly. I can't believe that this kid, I have known him longer than this kid, and he bet me.
What did you get for it?
A Westfield coffee.
You drink coffee?
No, cappuccino, you started that habit.
Well played, friend.
Thanks.
Enjoy your cappuccino.
Thanks, I will. See ya.
All right.
Bye.
Love you.
That was recorded, by the way.
Yes, it was. You don't know I've known your mother longer than you.
I'll win the next one.
That was a good one. It was a good one. I only bet when I know I'm gonna win.
I will time this cappuccino on a day that like Caleb doesn't want it.
Okay, let's see.
I think we better write that on the board so Caleb doesn't forget.
Can we make that a club 16?
I stopped at West School almost
Let's see.
this morning. This week I won't be grounded from.
I'm grounded from monsters. Okay, couple things I would like you to write down. You- Oh my gosh! No, we're all, like she said, we're all born in the same year. And you-
My dad is close to 51. That's why I had it as opposite. I had her older than my dad back because we're
You
almost
just
in
had a chance.
April.
They even do it.
Do you not even know when your mother's birthday is?
August 12.
6. No, no, it's not.
Yeah, no, you're right. 12 is John.
It's 6.
Yeah, 6 is my mom. 12 is John.
Yeah.
That's why you can't have them all in the same month. Like, I am okay to forget one of their birthdays.
No. If they're all in the same month, you don't have an excuse because you only have to remember the number. You don't have to remember the month too. It's easier.
I don't know.
Mason, I just found out that you have another sibling.
Yeah, Logan.
Yeah.
Well, my parents don't even have to try to remember my birthday. They just like give birth to them on Pearl Harbor.
You may decide you want to write these in your notes, or you may not, on your purple paper of all the things that you need to memorize.
Yeah, I'm putting it on my purple paper. Dude, I might have to flip over to the back. My purple paper soon.
I don't feel like this one is worth writing down, but
Okay,
Is
never
it
mind.
just the, is it just one that you've already learned backwards?
yep, thank you.
Wait, so these are just the ones we already know, but backwards.
Yep. What is this one?
Never mind, I'm good.
Tangent? I think it.
No, that's
You can't square them.
Okay, this is
Yeah, they didn't write it.
antiderivative. So what is it? Secant.
I was.
That was my second guess.
Okay. Because the derivative of secant is secant x tangent x.
We already have this in our notes, kind of, because we just have the other way.
Yeah, you just have it the other way.
I'm not writing this down.
That's fine. You don't do it. Okay. How about the integral of cosecant squared?
Cotangent.
No.
Negative cotangent.
Bro, no, I get these. Yes.
Okay. Why is it negative?
Because
Avery? Why are you talking? I have this weird, echoey, low voice. Because the derivative of cotangent is a negative cosecant, and so you got to put the negative somewhere. Okay, this one you may want to write down.
Wait, Avery, talk to me. I want to hear how low your voice is.
Okay, listen to me, please. This one you should write down. Okay, this is the integral of any exponential function. Okay, I'm pretty sure we have b in our notes for b to the x.
Yeah.
Okay, so we'll go b. Is 1 over natural log b. Shoot, that's ugly. Natural log b times b to the x plus c. So the derivative of b to the x is natural log of b times b to the x plus c. But that one, that same thing that Caleb said, 1 times something had to equal the natural log of b. So you had to divide. So this guy is 1 over natural log b times b to the x plus c. Okay, got another one. This one you want to write down. Okay, because it's just weird. Okay.
Just made my day worse.
Okay. The integral of 1 over x. You feel like you know this one. So what do you feel like it should be?
Natural log x.
So the difference is that when you do the antiderivative, natural log has to hit absolute value in there. And the reason is because you cannot do you can do a negative number, like you could do a negative number into this equation, but you can't do the natural log of a negative number. So you have to have the absolute value in there. So that's the weirdness of that one. So those are the 2 weird ones. Otherwise, everything else is the reverse of what we've been working on. Question, though, well, I guess we haven't done this. What's the integral of 0?
Does not exist.
It's just C.
It's just c, right? Because it could be any constant.
Plus C.
Just c.
Can you ever have a minus c? No. Because that
Well-
would just be negative.
Plus
Negative.
It would be plus and negative. The c would just, because c itself could be positive or it could be negative.
So does C ever have value? Will you ever give it value?
We're doing that tomorrow. So yes. So tomorrow, let's see. Here's your homework for today.
There.
Um,
You have not had homework.
Oh, it's a worksheet.
Looks like you're in there. So I'm just saying, wonderful job.
I'm tossing some of these off also, so don't put it away yet.
Oh,
Oh my.
I got a piece of tape. Okay, but these take like 2 seconds, bro.
Okay.
Still 22 of them. But she said she would cross them out.
Hey, you are not doing 17 through 22 at all.
Cross them out or
Cross
leave
them
them
out.
for tomorrow?
Don't cross them out. We might do it tomorrow.
Oh.
You may cross off 13 and 14. And then that's all you can cross off. Though. So that just dumped you down to like.
What about 6?
If you are in the Gold Star Club, you may also cross off 1 and 2. Yes, 13 and 14 are also crossed off. And 16. 1, 2, and 16 you can cross off if you're in the Gold Star Club.
Oh my god.
Oh my goodness, this will take you 3 minutes in success class.
Hey, next test, we'll put
And then
me
you
in
said
the-
regular.
not quite-
Instead of the regular one.
13 and 14, and then 17 and down.
Yeah, you used to say that test blank.